Question 6, calculator based. Points A, B, and T lie on a line on an indoor soccer field. The goal AB is 2 meters wide. A player situated at point P kicks a ball at the goal. PT is perpendicular to AB, and it's 6 meters from a parallel line through the center of AB. Let PT be x meters, and let alpha equals angle APB, measured in degrees. Assume that the ball travels along the floor. Find the value of alpha when x equals 10. Let's label this as a C. So we have 1 meter, 1 meter. Since this alpha is related to this x, we got to use a right triangle ATP and a right triangle BTP. We will label this is a theta, and this angle is a beta. So for A, assume angle APT equals beta, angle BPT equals theta. So we have alpha equals beta minus theta. Also, we can figure out BT equals 5 meters. In right triangle ATP, tangent beta equals AT over TP. That equals AT is 7 over x equals 10. So beta equals arc tangent 7 over 10. In right triangle BTP, tangent theta equals BT over TP equals 5 over 10. So theta equals arc tangent 5 over 10. Go to calculator. So alpha equals arc tangent 7 over 10 minus arc tangent 5 over 10. Make sure you change the mode. Degree. Second tangent 7 divided by 10 minus second tangent 5 divided by 10. 8.43 degree equals 8.43 degree. Let's go to B. Show that tangent alpha equals 2x over x squared plus 35. We already got alpha equals beta minus theta. Beta equals arc tangent. This time, we will use x instead of 10. 7 over x minus arc tangent 5 over x. We will use this formula to figure out tangent alpha. tangent alpha equals tangent beta minus theta equals tangent beta minus tangent theta over 1 plus tangent beta times tangent theta. For tangent beta equals tangent arc tangent 7 over x equals 7 over x. Tangent theta equals tangent arc tangent 5 over x equals 5 over x. So we do the substitution. Tangent beta equals 7 over x minus 5 over x. 1 plus 7 over x times 5 over x equals 2 over x 1 plus 25 over x squared. This is a complex fraction. LCD is x squared, so multiply by x squared for each term. Simplify, you will get 2x over x squared plus 35. The maximum for tangent alpha gives the maximum for alpha. Find the derivative of tangent alpha. For C1, d by dx tangent alpha, that equals d by dx 2x over x squared plus 35. We will use a quotient rule. Denominator square. Then 2x prime times x squared plus 35 minus x squared plus 35 prime times 2x. 2x prime equals 2 times x squared plus 35 minus 2x times 2x. Simplify. 2x squared plus 70 minus 4x squared over x squared plus 35 squared. Simplify, we will get negative 2x squared plus 70 over x squared plus 35 squared. For C2, hence or otherwise, find the value of alpha such that d by dx of tangent alpha equals 0. Derivative of tangent alpha equals 0 means negative 2x squared plus 70 over x squared plus 35 squared equals 0, which means negative 2x squared plus 70 equals 0, because p of x over q of x equals 0 means p of x equals 0. Then 2x squared equals 70. X squared equals 35. X equals square root of 35. Because x is the distance, it must be positive. In order to find the value of alpha, we need to substitute the square root of 35 for x. Alpha equals arc tangent 2 times the square root of 35 over square root of 35 square plus 35 equals, second way equals 2 times the square root of 35. Square root of 35 square will be 35, so 35 plus 35. Enter. Then second tangent. Enter. Alpha equals 9.59. Alpha equals 9.59 degree. Let's go to C3. Find d2 by dx squared of tangent alpha, and hence show that the value of alpha never exceeds 10 degrees. We want to figure out a second derivative of tangent alpha. If we prove this alpha is a maximum value, then automatically we already proved this alpha never exceeds 10 degrees. So d2 by dx squared of tangent alpha equals derivative of negative 2x squared plus 70 over x squared plus 35 squared prime equals, we will use the quotient rule, x squared plus 35 squared, then squared, negative 2x squared plus 70 prime times x squared plus 35 squared minus x squared plus 35 squared prime times negative 2x squared plus 70 equals denominator x squared plus 35 to the fourth power. Derivative of negative 2x squared plus 70 will be negative 4x times x squared plus 35 squared, then minus. We got to use the power rule first, then chain rule. 2 times x squared plus 35, then times 2x times negative 2x squared plus 70. We need to reduce x squared plus 35 first. X squared plus 35 to the third power. X squared plus 35 left, negative 4x. This is gone. Negative 2 times 2x will be negative 4x times negative 2x squared plus 70. Denominator is x squared plus 35 to the third power. Distributive property, negative 4x times x squared will be negative 4x to the third power. Negative 4x times 35 will be negative 140x. Negative 4x times negative 2x squared is a positive 8x to the third power. Negative 4x times 70, negative 280x equals denominator x squared plus 35 to the third power. Numerator combine like terms, 4x to the third power. Negative 140x minus 280x will be negative 420x. Since this is a rational function, we can factor the numerator to see whether there is a common factor. 4x is the common factor, x squared minus 105 over x squared plus 35 to the third power. Hence, show that the value of alpha never exceeds 10 degrees. In other words, we need to prove when x equals the square root of 35, this alpha is the maximum value. d2 by dx squared of tangent alpha. X equals square root of 35 equals 4 times the square root of 35 times the square root of 35 squared minus 105 over square root of 35 squared plus 35 to the third power less than 0. So alpha equals 9.59 is the maximum value. In other words, the value of alpha never exceeds 10 degrees. Let's go to D. Find the set of values of x for which alpha greater than or equal to 7 degrees. We know tangent alpha equals 2x over x squared plus 35. If alpha greater than or equal to 7 degrees, which means tangent alpha greater than or equal to tangent 7 degrees. So we have 2x over x squared plus 35 greater than or equal to tangent 7 degrees. To solve this inequality, we will get greater than or equal to 0 form. So 2x over x squared plus 35 minus tangent 7 degrees greater than or equal to 0. Alpha y equals 2x over x squared plus 35 minus tangent 7. Then graph. We are looking for x-intercept. Zoom 6. This is a standard window. Since we are looking for the x-intercept, I will change the window for y, -1, 1, 0.5. Graph again. We need to change the window for x. Let's do from 0 to 30. 3. Graph. Still not clear. Change window for y. -0.2. 0.2. 0.1. Graph again. The solution will be the graph above x-axis. We need to figure out these two x-intercepts. The solution will be between these two x-intercepts. How to show your work for solving inequalities. Normally, solving the equation first. Solve 2x over x squared plus 35 minus tangent 7 degree equals 0. X1 equals 2.55. X2 equals 13.7. We know the graph above x-axis is the solution to the inequality. So x greater than or equal to 2.55, less than or equal to 13.7. Remember, when you solve inequality, show the work to solve equation to get the solution. Then you can get the solution to the corresponding inequality.